My name's Talon Miller. I am a senior technical product marketing manager at Redis. And the picture on the right, since we just mentioned skiing, is actually one of my favorite places in the world. It's in Snowbird. And the picture on the bottom is me and my wife. We've been married for just about 5 years. We have no kids, no responsibility there. We're kind of just enjoying, our lives, which is great. And then in regards to work experience, I started my career while I was still in school at Oracle a long time ago as a systems engineer. So I got really familiar with, frameworks, different databases, especially Oracle database. And actually, at the end of my time at Oracle, I started working at Oracle Cloud. So pretty familiar there. And then after Oracle, I went to a crypto startup, really in the early days of crypto, and I did product marketing and other things for them there. And then I went to Domo as a data scientist consultant. Got to work with some really awesome PhD level data scientists doing some really cool things. For those who don't know what Domo is, it's a BI platform. Really enjoyed my time there. I did some professional services for them as well. And then eventually came to Redis to do some product marketing. So that's a little bit about myself. So agenda today. So we know that Redis changed the database world with its sub-millisecond speed and ability to process millions of operations per second. And container technology alongside Kubernetes has completely transformed orchestration in the DevOps lifecycle. But sometimes, if not a lot of the times, it's really hard to realize the benefits of Redis and Kubernetes. So how do we get these two amazing technologies to work well together? And for all those who are listening who don't have Kubernetes in your tech stack, I know there's a saying in the industry, you're either a Kubernetes shop or you're not. I would just like to say, if you're not a Kubernetes shop and you're like, oh, this is about Kubernetes, this presentation won't just affect people who are using Kubernetes or thinking about Kubernetes. I'm essentially going to be telling a story about how some technologies are super, super hard to use and to automate. Kubernetes, of course, makes that easier. I'm not trying to convert you to Kubernetes, but just keep an open mind that if there is a particular technology that you're using today that you find hard to integrate with other technologies in your technology stack, I'm going to be telling a little bit of story about that with Redis. So in my presentation today, we'll cover how the strengths of both Redis and Kubernetes make for an awesome match, how the Kubernetes operator comes into the equation, look at where we can deploy Redis Enterprise on Kubernetes, and then finish with a roadmap sneak peek. So let's dive in. So building out Kubernetes in your tech stack can be pretty complicated. Some of the technologies pair really well with Kubernetes because of their easy integrations to allow a simple deployment. Others are quite difficult, such as Redis open source. In order to take advantage of the real-time capabilities of Redis, building Redis open source on Kubernetes requires advanced init scripts, firewall rules, service discovery, and that's just the start. Even with this complex deployment, Redis open source on Kubernetes isn't perfect. Manual intervention is needed with Redis version upgrades or resizing of existing cluster VMs, just to name a few of the challenges. So how do we address these challenges? Redis Enterprise along the Redis Enterprise operator is the standardized solution for Redis on Kubernetes that is far more reliable, scalable, and enterprise supported. It was built to not only be resilient, but flexible enough to fit in with existing deployments of Redis open source, which is huge because we know that millions and millions of people use Redis open source and start with Redis open source. So the fact that we were able to get the operator to work with Redis Enterprise and the deployments of Redis open source is huge. It also integrates really well with Helm and Terraform. So we'll move on. Operators were developed to tackle the sophistication that stateful applications bring. The operator fills the gap between the capabilities and automation provided by Kubernetes and how Redis uses Kubernetes for automation of tasks. It's what we like to call an expert in a box, based on our own experience running Redis at scale in Kubernetes. Redis has created an operator that deploys and manages the lifecycle of a Redis Enterprise cluster. The Redis Enterprise operator is the fastest, most efficient way to deploy and maintain a Redis Enterprise cluster in Kubernetes. Without the Redis Enterprise operator, running Redis on Kubernetes can fail to react accurately to internal edge cases and failure conditions. Also, Kubernetes orchestration runs outside of the Redis cluster deployment and could trigger failover events in split network scenarios, for example. The operator helps by splitting responsibilities between operations Kubernetes does well and what Redis Enterprise excels at, so both can orchestrate together. The operator allows Redis to maintain a unified deployment solution across many Kubernetes environments like GKE, AKS, Red Hat OpenShift, VMware Tanzu, EKS, and more, providing seamless portability to deploy, manage, and move applications to and from any cloud, multi-cloud, hybrid cloud, and on-prem. So Kubernetes and cloud native environments require that storage volumes be network attached to the compute instances to guarantee data durability. Otherwise, using local storage could lead to data loss in pod failure. For example, Redis Enterprise uses network attached storage for data durability. In this case, when a pod fails, Kubernetes launches another pod and automatically connects it to the storage device used by the failed pod. Redis Enterprise then instructs the other Redis Enterprise databases instances running on the newly created node to load the data from the network attached storage to guarantee a durable setup. Redis Enterprise should also be recognized for its ability to efficiently use persistent storage. I think this is huge. Even when configured to write every change to disk, compared to a disk-based database that requires multiple interactions with a storage device for every read and write operation, Redis Enterprise uses a single IOPS for a write operation and 0 IOPS for a read operation, providing significant performance improvements in typical Kubernetes environments, making write requests up to 100 times faster and read requests up to 500 times faster than a disk-based database. Another really interesting thing to note is that in a traditional Kubernetes environment, usually one pod includes one service, right? That's how it's always been done. We found that it is highly inefficient. Redis Enterprise is exceptionally fast, and in most cases can use just a fraction of the CPU resources to deliver the requested throughput. Meaning, when running a Redis Enterprise cluster with multiple Redis Enterprise instances across multiple pods, the Kubernetes network with its multiple vSwitches can quickly create a bottleneck. So Redis took a better approach. Deploying multiple Redis Enterprise databases in a single pod allows better usage of hardware resources used by the pod, such as CPU, memory, and network, while keeping the same level of isolation. So in the end, we can leverage enterprise-grade operational controls for high availability, security, seamless scale, ensure instant failover and automatic recovery to protect applications against unplanned downtime, outages, and data loss. And finally, automate database provisioning, management, and maintenance, and lean in on the self-imposed regulatory compliance, regulations, and standards built in security controls and encryption. So how does it work? So the Redis Enterprise operator supports 2 custom resource definitions: Redis Enterprise Cluster, or REC, and Redis Enterprise Database, or REDB. The REC is an API that creates the Redis Enterprise Cluster, and the REDB is an API that creates Redis Enterprise databases running in that cluster. First, the Redis Enterprise Cluster custom resource is read and validated by the operator for a cluster specification. Then cluster stateful set, service rigor, cluster admin secrets, Redis software and UI services are created. Then a Redis Enterprise Database custom resource is read, like we just mentioned, and validated by their operator. This is where we can enter in the fields in the YAML file to really configure what you need for your deployment. And then the database is created on the cluster, and the database access credentials are stored in Kubernetes secret object. And then the service rigor discovers the new database and configures the Kubernetes service for the database. Lastly, an application workload uses the database secret and service for data access. So let's look at a quick example of how we can automate tasks using the Redis Enterprise Kubernetes operator. So if we have a YAML file like this, and if you change the nodes from 3 to 5, the operator talks to the stateful sets and changes the number of replicas from 3 to 5. Once that happens, Kubernetes will take over and bootstrap new nodes one at a time, deploying pods as well. As each one gets stood up, the new nodes join the cluster and become available to Redis Enterprise primary nodes. So we'll accompany the Redis Enterprise cluster resource YAML file with this Redis database resource YAML file. Nothing special here. We're just establishing that we want 2 gigs of memory, but there are so many, like literally dozens of different fields that we can configure in this YAML file to nail down the kind of deployment you need, depending on your business need. The operator discovers the resources, talks to the cluster REST API, and then creates the database. The server talks to the API and discovers it. Then a Redis database service endpoint is created. Then we are good to go. This ultimately enables the ability to develop highly scalable microservices-based and Kubernetes orchestrated applications quickly and anywhere. So with that, let's turn to a roadmap sneak peek. We just recently released Redis on Flash for Kubernetes, which is really exciting. For those who don't know about Redis on Flash, is essentially it's data tiering, where we can put larger data sets into SSD, not RAM, which provides a huge cost savings without compromising a ton of performance. And then the last thing that's coming up in the next couple of months is active-active. And for those who don't know what active-active is, it's essentially geo-replicated databases. And it's a huge deal, right? So if anyone's ever set up active-active before, which is essentially, setting up clusters in multiple regions that can fail over to each other and replicate to each other, it's very difficult. And even if you've got the process down and it's no longer difficult, it's still very time consuming and it takes a lot of maintenance as well. So we're going to be allowing and enabling Redis Enterprise on Kubernetes to set up an active-active cluster with a YAML file, which is pretty insane. It's just going to be like 1 or 2 lines, and it will be by far the fastest way to set up an active-active Redis Enterprise cluster in any deployment. So really excited about that, which will come out hopefully early spring, late spring. We'll see. So that's it. You can enable teams to spin up Redis databases through YAML manifests, completely removing the headache of node management for your Redis Enterprise cluster, all without client code changes on a fraction of infrastructure on-prem or any cloud. So if you want to learn more, I've recently created a lightning demo on how to get set up on GKE with the Redis Enterprise operator on Kubernetes. So go check it out. It's on YouTube. And if you have any questions, feel free to ask me or email me. So yeah, thank you.